12 learners, welcome to today's technical mathematics lesson. My name is Matsiriso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Remember, our WhatsApp number is 079-454-9535. I'm repeating, grade 12, 079-494-9535. You are more than welcome to send any of your question or clarity seeking question to that particular number, or any solution that you want to share, you can share on that particular platform. Thank you very much. Now our today's lesson is on the last push, revision on paper 1. Alright, remember grade 12, we have topics that are specifically for paper 1 and their specific weightings. Remember, we have algebra, we have functions and graph, we have finance, growth and decay, and differential calculus and integration. Our focus for today will be on finance, growth and decay, together with the differential calculus and integration. Look at the weighting or mark allocation for each topic. Algebra, it weighs a lot, grade 12, that is 50 plus minus 3 on your paper 1. And then second, we have functions and graph, that is 35 plus minus 3. Finance, growth and decay, that is the lowest with 15 plus minus 3, followed by the differential calculus and integration, which worth a big mark, grade 12, which is plus minus 50. Those are the weightings for your paper 1. And then you have your information sheet that will be at the back of your question paper with all the formulae that you need in this particular paper, for both paper 1 and paper 2, but specifically today we'll look at the ones that you will apply only on paper 1. So now you have the first class, that is algebra, functions and graphs, of which is composed of quadratic equation, the x turning point of a quadratic function, the y turning point of quadratic function, exponential equation, and the logarithms. Remember, you are not looking at algebra and functions for today. Our focus will be on finance, growth and decay. And then below the finance, we are having 3 formulae. That is the simple interest one, the compound interest, the effective and the nominal rate. And then with the simple interest, we are having an appreciating one, which is with the value that is going up on simple interest, or the one that is decaying, reduced with a minus formula there. But this one is having a relationship with a linear function. As you can see, that the equation is of a linear one. Okay, as you can see, even if it is a decay one, it will be linear. Linear straight line, remember, grade 12. And then we have the compound interest formula. What is the difference between the two is that now your n is now an exponent. And then now if the value is appreciating, going up, that means you will use the plus one. And then if it is a depreciating or a decay in your statement, then you will follow the one with the minus sign. How do you know is compound and must be on an exponent? How do you know is simple interest and must be linear down there? And then now with the simple interest, they use abbreviation SI. And then with the compound interest, we use the abbreviated one as BCI. And then now followed by the effective and nominal rate formula. You also found this on your formula sheet. That is I effective is equal to 1 plus I nominal. That I on top is the I nominal. And then over M to the power M. This M here is talking to the compounding. Compounded monthly, compounded daily, compounded quarterly, and so forth. And then that formula is followed by a minus 1 day. So you only use this one if you are calculating an effective rate or you are calculating a nominal rate, depending on the question given to you. And then now followed by differential calculus. With differential calculus, we have only one formula, which is of the first principle, and the formula says that f derivative of x is equal to the limit of h approaching 0 of f at x plus h minus f at x, and then everything over h greater 12. Please ensure that this dash is there on your formula. Without that dash, it is no more a first principle formula. Ensure that the equal sign is before the limit. You cannot put that equal sign after a limit. That will be a notation error, grade 12. And then now from here we must have h approaching 0. Some learners, they put an x there instead of h. It must be h approaching 0. And then starting with f at x plus h followed by the minus f at x. Please always double check with your formula sheet to ensure that you have copied the formula correctly, so before you can start with your calculations. And then we have the integration, which is the last topic on your paper 1. And then with the integration, now we are having the rules that we are following there. That is the first rule. The second one, they look similar. This one is having coefficient 1 there, and then there you have a constant number. It can be 2, 3, and so forth. Okay, and then with the second one, you can see that it's where you are having 1 over a fraction. Now, as you can see, the top part is 1, and then it is a fraction over x to the power 1. X to the power 1. You cannot apply this if it is x to the power 2 and so forth. It must be x to the power 1 grade 12. And then now, followed by this, they have a relationship. The only thing is that the k represents any constant number there, whereas the first one, it is strictly only for 1. And then the last one is where you are having an x as an exponent now. Look at x there, it's exponent. And then this one is having coefficient there of a being a number 1 and minus 2, any number there. But this one is specifically for a coefficient 1 there. And then now with this one, also on the exponent, you are having a coefficient of x there being n. It can be any number. Whereas for this one, it is also 1 there. Okay, that is the difference between the two, but they are classified in a way that they share information. This one, they have relationship with that one, and then this goes with that one, and then this also goes with that one. It's only that we have changed the coefficients in some cases there. Right, and then now with finance, growth and decay, remember we said on your paper it will be 15 plus minus 3 marks. And then now there are representation of each letter in the formula. Remember, I've already talked to the formulas that you'll be using on finance, growth and decay. So the letter A is for the final amount, and then this amount, it doesn't matter whether it was an investment or it was a money borrowed and so forth, whether it's an appreciating amount or depreciating. So when we talk A, we talk the final amount, either after appreciating or after the depreciate, after growth or after decay. So that is the amount you are talking to there. It's not specifically grade 12 for a growth. It can be A for decay, okay? And then now the P there is the principal amount. That means it's an initial amount, an initial price of a car, initial price of a furniture, or the initial money that you invest in a certain account. That is the P, principal amount, of which is your initial amount. And then we have I, the smaller I here indicates the interest rate. The money is invested at 10%, or the interest is added at 15% and so forth, okay? That is the interest rate. As inflation, we know that they are inflating in our country with 15%, so that is the interest we are talking to. It is in percentages. And then when you have capital I now, that is the total interest added, okay? That is the total interest added to what? To your amount, to the principal value, so to the value that you invested. That means now this I will be in the total amount that you receive now. Remember, when you invest, you'll have the money that you've invested together with the interest added on that one. So the capital I is indicating the interest gained on a investment, or the interest gained when you borrow money and so forth. But this one is the rating. The smaller I is in percentage. That is the difference, grade 12. And then the number of periods n indicate, it can be in years, it can be monthly, it can be quarterly. It depends on the compoundment in some cases. So that is the number of period your money spent on an investment, or the number of period of which you will borrow a specific amount of money. And then I effective, remember we've talked to effective formula. So IEFF stands for the effective interest rate. This is also in percentages. And then I nominal, IN indicate the nominal interest rate. On your formula sheet, they've just indicated I. You must know is for I nominal. And then M is for the different periods of compound growth and decay. Remember, we can compound quarterly, semi-annually, half-yearly, daily, monthly, and so forth. And then now, the periods of compound growth and decay, we only compound on compound interest, grade 12. On the CI, we apply this compounding periods, okay? And then now they are divided. You can compound annually, compound semi-annually, or half-yearly, or biannually. Bi means 2, that means it will be twice per year. And then that happens after 6 months. They can sometimes say after 6 months. So how many 6 months do you have in a year? 2. Therefore, it will be twice. They can say half-yearly. You must know it's half of the year, which is exactly 6 months. And then they can also say semi-annually. Semi means half. Remember, semi-cycle is half of a cycle. The same applies here. If we say semi-annual, we mean half-yearly. Annual, remember, it's a year. Okay. Now, quarterly, how many quarters do you have in a year? We're talking 3 months' time. That is 3, 6, 9, 12. That means we have 4 quarters in a year. And then they can compound monthly. They can compound weekly, compound daily. And then now when we talk the annually or the yearly compoundment, that means it will happen only once. What is happening now? Let's say you have invested the money and then they are saying they are compound this yearly. That means the interest will be added only once per year into the money that you have invested. If you invest for a period of 5 years, that means your interest will be added only 5 times if it is compounded yearly. And then now, number of terms, it will happen only once in a year. And then it is not affecting your I and N, because this compounding now, they have an impact on the I value and the N value. But with the case of the annual or the yearly compoundment, this is not affected because it will be I over 1, which is still I. And then 1N, which is still N there. So no change on your I value and the N value. But when coming to biannually, after 6 months, half-yearly, semi-annually, it happens twice in a year. So if you invest for 5 years, that means it will add interest twice in the year. So it will be added 10 times in 5 years, okay? So now that means number of terms in a year, when you compare to 1 year, it will happen twice. So how does this affect your I? It will be I divided by 2. And then for the period, it will be 2 times N. Okay. And then quarterly, after each 3 months, that means it will be 3, 6, 9, 12. Since we have 12 months in a year, we always compare in terms of the year, grade 12. That will be 3, 6, 9, 12. As you can see, it will be 4 times. Hence, we are saying 4 number of terms. Then I will be I over 4, and then 4 multiply for the number of periods there. And then the monthly, if it is happening monthly, within a year we have 12 months. That means every month, January, they will add a profit, February, March, up to December. So the interest will be added 12 times. So that means it's 12 terms. And then I will be I over 12, and then N will be 12 times N. And then now weekly, in a year we are having 52 weeks. And then the number of terms will be 52. I will be I over 52, and then the period will be 52 times N. And then lastly, we have the daily compoundment. On this one, the interest is added every day on daily basis. So that will be 365, and then that will be I over 365. This is a normal year, of which is not a leap year. If it's leap year, it will be 366, okay? But now, Mostly they use a normal year, which is 365 days. And then that will be I over 365, and the 365 multiplied by n. Remember, this happens only if you are on your compounding interest. Compound interest. Check the compounding there on your statement. And then now under finance and growth and decay, we have keywords that can guide you, grade 12, because when you read a statement, it's very difficult for you to decide whether am I taking a simple interest or a compound interest formula. That's the first thing that you need to do. Identify the correct formula before you can start your calculations. So now, if you are on a statement that needs simple interest application, you look for the following keywords. You look for the simple interest itself. You look for SI, of which is the abbreviation of simple interest. You look for the word straight line basis or linear base or the hyperchase. The minute you can see all of this, you must know they are only talking to what? To your simple interest. Those are the keywords that you can look for on your statement. And then with the compound interest, now in order to select the compound interest formula, you must look for the word that is directing you, compound interest, or look for CI, abbreviation of compound interest. Look for the word reducing balance, and then or check for population growth. The minute they talk of a population of a certain nation and so forth, you must know that is a compound interest calculations. And then they can take the inflation of our country and so forth. You must know that you need to apply the compound interest formula. And then the compound interest is having a relationship with the exponential graph. That means your information can be given in a form of a graph. If that graph is exponential, that means it is talking to a compound interest. If it's a linear graph or a straight line, you must know it's a simple interest. Okay, and then now when coming to selection now of the plus or minus formula, now you have identified, look for the keywords whether you select simple or compound. After selection of either simple or compound, you now select in terms of is it a minus or is it a plus equation, because simple is having both and also compound is having both minus and plus. So now in order to use a minus formula for simple or minus for the compound, you need to look for the following keywords. Remember, this one is for simple interest, that one is for compound interest, n is on the exponent. So you look for the depreciating. When you depreciate, the value goes down, then it's a minus formula. A decay, a certain loss of amount, a decrease, a reduce. The minute you see those keywords, you must know that the formula that you'll be using, it will be a minus one, either being simple or the compound one, grade 12. And then with the plus one, this is for simple interest, and that one is for compound interest. And then with the plus one, you check for the word appreciating. The minute it says the value is appreciating, or there's a growth in value, or there is an interest gained, and then or there is an increase in amount, therefore this is a plus formula, either simple or the compound interest. So I hope these keywords will assist you in making correct decisions, grade 12. And then let's look at the first activity under finance. The statement says that the nominal interest rate, okay, the nominal interest rate, I am highlighting that because now it is talking to nominal, that is charged on an investment is 7.2. That means I am giving I nominal, which is equal to 7.2% per annum. And then compounded half yearly. Remember, when you talk compounded half yearly, how many times does it occur? Twice. Okay, compounded half yearly, that means my I will be affected by 2 and the N will also be affected by 2. And then the minute I see this word compounded, I know that I will be using a compound interest formula. Okay, and then now Okay, this is compounded, it's fine, it's fine. And then calculate the annual effective rate now. Oh, in this case now we have to calculate the annual effective rate. Oh, grade 12, yes, we are not looking for anything from compound interest, but we are depending on the effective rate formula, because the question says that calculate the annual effective rate. And then now, so we have compoundment, which is 2, and then we have the nominal, which is 7.2, and then now compoundment M is equal to 2, because it is happening half yearly, twice per year. So we can now go to our formula of effective. That will be I effective is equal to 1 plus I nominal over M for compounding minus 1. And then secondly, you now substitute now. Remember, we are looking for I effective there. That will be still 1 plus, we are now substituting I nominal, which is 7.2%. Grade 12, do not bother about changing percentage to decimal. Your calculator is having a percentage button. You can use that button effectively. So, and then the M is 2, and then remember it will be the same as that one. Okay, and then a minus 1. Can you see now everything is substituted on the right hand side? No need for partial simplification, grade 12. You can put the whole thing on the right hand side into your calculator straight to the answer. So you just say 1 plus 7.2 and then shift, and then you go to the percentage button on the fraction form, and then below you put in the 2, and then on an exponent you put a 2 minus 1. Then the answer for this one will give you a decimal answer, which is 0.073296 and so on. But remember, because it's an effective rate, small I is always a percentage, grade 12. So whatever answer that we get there, we are going to multiply this by 100 so that this can change to a percentage, right? And then this will give us how much? 7.33, because now we need to take 2 decimals after a comma, as stated on your instruction sheet at the beginning of your question paper, unless stated somewhere here that round off to certain decimal places. If it is not indicated here, you follow the ones on the instruction sheet which says 2 decimal places after a comma. Hence, we can see that we have taken 7.33, then this will be in percentage because you have multiplied with 100. Okay. And then question number 2. Homolemo buys a cell phone from the Kudu, which cost 3,000. That is the price of that cell phone. Okay. And Homolemo is willing to pay off the cell phone over a period of 1 year. All right. And then the Kudu calculates what he will receive from Homolemo if he charged interest of 9.2 per annum. Now the Kudu is charging 9.2 per annum, and then this is compounded daily. Interest is added every day to that particular value of a cell phone. Okay, and then now let's try now collecting our data, grade 12. You must be able to identify this 3,400 is the value of what? Because it's the cost, that means it's the initial price of that cell phone. Therefore, it will be a principal amount. Initial price, principal amount. Then our P will be equal to 3,400. Okay? And then now for a period of N is 1 year. And then now the I is going to be 9.2%. And then it is compounded daily now, 365. That means this N will be multiplied by 365 because of the compounding, and then the rate will be divided by 365. As we calculate, we will be using that compoundment. Now we have now applied everything into our statement with a sense of understanding what is given to us. It's only then that you can look at the question now, grade 12. The first question says that calculate how much Khomolemo must pay in total to the nearest friend. Remember now, if an interest is added, that means the value is going up, right? That is the first thing. It's a positive formula. And then if we see the word compounded, that means it's a compound interest. Okay, we know it's a compound interest formula because interest is added, therefore it's a positive formula. So it will be A is equal to P into 1 plus I to the power n because it's compound interest. What is P? 34,001 plus, what is I? 9,2% over 365 of compoundment. And then now to the power n, n is 1 times 365. 1 year times 365 compounding. And then you put everything into your calculator, grade 12, and then straight to the answer. And then this will give us a 3,727,60 cents. Do not take anything more than 2 digits after a comma. There's no way you can have 129 cents. No way. So we only take 2 digits. We cannot take 605 cents. No. 2 digits after a comma. Ne? And then now always do this as your final answer there. There we are now. That is the how much Khomolemo must pay. So the price is 3,004, but Khomolemo in total, because of the interest, will pay 3,727 rand 60 cents. And then question 2.2 states that did the Kudu offer Khomolemo a good deal, grade 12? It depends on you whether it's a good deal or not, because you need to compare this amount with the initial one. As you can see that the difference between the two now, it will be 3,727.60 minus the 3,400. So if we minus the 2, we are left with the difference between the two is 328. Okay, 40 cents there. That is the difference added on top of that amount that was the initial price of the cell phone. And then now, if you say yes, it's a good deal, then you'll tell us that maybe the interest was less. So we will accommodate both answers being a yes or a no. Because if you say yes, that means you can afford the interest of 3 to 8. If you say no now, you'll indicate that is too much interest, of which you feel it's unfair to Khomolemo as given by the Hudu, those conditions. Okay, grade 12, both, as long as the motivation statement, it talks to a yes correctly so, or it talks to a no correctly so, then you'll get your full 2 marks there. Okay. And then the first mark now on number 1, it will be for the selection of the correct formula there. And then the second mark will be for the substitution, correct substitution into the formula. The third mark will be for this part that you have compounded there. And then lastly, the fourth mark will be for the value 3727 there. That is how we allocate those 4 marks there. And then with question 2 now, it will be for saying yes and the reason, that valid reason that will be given there. And then if you say no, you must also give us a valid reason relating to your calculation in number 1. Then you'll get each mark for that, of which is your 2 marks, depending on your answer there. And then number 3, for B invested an amount of 20,000 for a 6-year period now. She earns 12.5% interest per annum compounded monthly for the first 2 years. Remember, the investment is for 6 years, and then for 2 years is having a certain interest rate. Thereafter, the interest rate changes. The minute you have those change in interest rate, change in deposit, that means it's more than one investment that is happening on the same within the investment that you have done. There are changes within. That means it's a timeline type. Okay, grade 12 is a timeline type. That means now you need to analyze the statement carefully, so because if you can miss one thing, everything will be wrong in that particular statement. So we need to be very careful, grade 12, when you are answering that. And then let's start now. Poppy have invested. This is the starting of the investment at the beginning. How much is invested? 20,000 for a period of 6 years. So this whole investment, it will be for 6 years in total. But there is something that is happening in between. She earns 12.5% interest per annum, compounded monthly. And then for the first 2 years. So out of these 6 years that we are having, the first 2 years, that interest will be how much? 12.5. It is compounded monthly. That means it will be over 12. N was supposed to be 2 because it's for 2 years. Because it is compounded monthly, it will be multiplied by 12 for the first 2 years. Okay. And then thereafter, after that 2 year investment, the interest rate changes to 9.8 per annum, compounded quarterly for the rest of the investment. Remember, the total investment is for 6 years. And then for 2 years, we have dealt with that because we have indicated within this period that is what is happening. So out of the 6 that we are having, we have dealt with 2. That means we are left with 4 years now. So this one will take the remaining 4 years. And then they say the interest rate for this one will change to 9.8%. Look at the compoundment, compounded quarterly, no more monthly. It is changing to quarterly. Quarterly, remember, is 4 times in a year. Therefore, it will be divided by 4. And then N for this period of 4 years, it will be 4 years times the compounding, which is 4 times. So that is the total investment that is happening within whatever money, 20,000 invested. And then now determine the amount that she would have saved at the end of the period. The minute they say she is saving a certain amount, the formula will be plus. And then because it is compounded, it will be of a compound interest rate. Selection of the correct formula is very important, because incorrect formula, 0 grade 12, doesn't matter. You have substituted correctly and so forth. We look at the formula. If the formula is incorrect initially, everything goes into the drain. It will be a 0 for the whole question. So please ensure that your formula is correctly selected. So now we are having the compound. So the first investment within 2 years, what will happen is that we are going to invest 20,000, compound interest formula, and then that will be 1 plus I. What is I here? Is 12.5% for the first 2 years over 12. And then this is for how many years? For that period there, 2 times 12. Okay, you can work out that part and find the answer. It's fine. And take that amount and invest on the second investment of 4 years. All right, or you can do it automatically on one timeline, because the amount that you will get within the period of 2 times 12, which is 24 months, will be invested again for the next 4 years. So we are taking this amount here. We will be investing this again for a period of 4 years. Still on compound interest is this amount invested into 1 plus I. Our I now will be 9.8% compounded quarterly. And then for a period of 4 times 4. So grade 12, you can put everything into your calculator straight to the answer. And then this will give us how much? 37,000 in total. After 6 years, we will be having 37,000 in that investment if you are investing and changing according to what is indicated there. So now you save money, 20,000 for 6 years. After 6 years, within this interest rate, you will receive 37,777.52. Grade 12, you can also do your own calculations before you start investing by checking different interest rate from each bank so that you can choose your investments wisely. So, okay. And then now, differential calculus and integration. We are done with the finance grade 12. We are moving to the next topic, which is differential calculus and the integration, of which is 50 plus minus 3 marks. Let me give you 2 minutes so that you can try to work this on your own, and then after 2 minutes we'll check your solution grade 12. Let's just check how far can you go then within this particular problem. Okay, grade 12. Let's check now how far did you go with this one. And then remember our WhatsApp number 0794549535. You are more than welcome, grade 12, to send your clarity seeking questions to that particular number. Now, with the differential calculus, the first question that will be starting, it will be on first principle. Remember now, I've indicated to you now, for this formula to be correct, there must be that dash there. Okay, equal sign must be before the limb, not after the limb. And then this must be h approaching 0, not x approaching 0. And then we are starting with f at x plus h, and then followed by the f at x, not the other way around, grade 12. Please take care of that by double checking on your formula sheet that you have copied the formula correct. That is the first important thing. And then now, if you look at this formula now, you can see that it needs your f at x, of which you already have, of which is what is given to you. And then you also need the f at x plus h. So that is our starting point, grade 12. We are going to identify what is f at x plus h. But good enough with the first principle, the answer is already there for you, grade 12, because you only do the linear one. So the answer will be the coefficient of x. That means after using the first principle, we are expecting our answer to be a minus 3 here. The coefficient of x is minus 3. So we are expecting our answer to be a minus 3. But now we start by looking at f at x plus h. So out of this f at x formula, we are going to substitute our x by x plus h. Wherever we see an x, we will put an x plus h into a bracket, grade 12. And then can you see now you need to multiply or distribute minus 3 into the bracket. Then we are going to do exactly that. That will be f at x plus h. Then this 5 is not part of the bracket. It's only minus 3 that is multiplying into the bracket, not a 5. Ne? And then the 5 will remain 5 there. And then minus 3 times x will be minus 3x. The minus 3 times h will be minus 3h. Therefore, this is your f at x plus h. That is your starting point. Then you will have your first mark now at that particular point out of 4. And then now the next step now is taking your formula from the formula sheet. F derivative of x is equals to the limit of h approaching 0 of f at x plus h minus f at x, and then everything over h. This division line, grade 12, is not including the limit. Starts from f at x here, okay? F at x plus h. Now let's do our substitution. We continue with our equal side. You bring down the lim of h approaching 0, grade 12. Do not put some dashes like that, because that is 11 in mathematics. The meaning of those two dashes is 11 in maths, nothing else. So now you write the lim as it is. This is the limit of h approaching 0. And then now we substitute f at x plus h, which is the answer we have there. That is 5 minus 3x minus 3h. And then it's a minus from the formula there. And then now we put our f at x. So if we look at f at x is 2 terms, then we'll put a bracket in order to take care of the negative out there. And then this will be 5 minus 3x there. And then all over h. After substitution, that will be your second mark, correct substitution into the correct formula. And then now we need to remove this bracket here into f at x by distributing a negative in there in each term. And then we bring down our lim of h approaching 0. It must always appear the grade 12. If you miss it somewhere, you will have a notation error. 1 mark will be lost because of notation error. That limit of h approaching 0 must always be there. And then that is 5 minus 3x minus 3h minus 5. It's a negative 1 into multiply by 5, that is minus 5. And the negative 1 multiplied by minus 3, that will be a positive 3x. And then all over h. And then grade 12, at this level, after removing the bracket from f at x, there must be a cancellation of terms. And then that f at x of yours must all disappear. If it doesn't disappear, that means we have made a mistake somewhere. So it will be a 3x minus 5 plus 5. Opposite sign, same value. Then they cancel and equals to 0. And then as you can see now, you are left with only the terms that are having h's. Okay? At that step, the only thing that must remain is everything that is having h. The minute there's an x remaining there without an h, you must know you are going wrong. And then now we have the limit of h approaching 0 of minus 3h over h. Then at this stage, the h will cancel an h there, and your answer will be minus 3. Can you see our prediction is 100% correct? We have predicted that the answer will be the coefficient of x, which is minus 3. If you don't get that value, grade 12, that means you went wrong somewhere. It must be exactly like that, okay? So we said the first mark will be for f at x plus h, the second one for substitution, the third one for simplifying this and end up with minus 3h over h, and the last one will be for the answer. That is your 4 marks. Sometimes the examiner gives this question 5 marks. If it is 5 marks, they will also give you a mark for simplifying at that particular step. Okay. And then now we can have the limits also on differential calculus. And then the limits now, before you can do your lim, you must simplify the expression that is given to you as far as possible before you can apply this lim of x approaching minus 2 there. So now we look at this part there. Is there any simplification needed there? Yes, because you are having a quadratic equation on top, on the numerator. That means you need to factorize that quadratic equation. Okay, let's bring our quadratic. You can even use your quadratic formula to check that, okay? But here we are going to look at the factors of 2. When you add, they give you a 3. You know that factors of 2 are only 1 and 2. When you multiply them, they will give you a 2. But when you add them, they will give you a 3. That means this is what we are looking for. Because the trinomial is saying factors of 2, when you add them, you must get a plus 3. So they must both be positive in order to get a 3. So now we have our factors. This will be the limit of x, approaching the minus 2. And then on top, we are having factors of this will be x plus 1 and x plus 2 all over x plus 2. After factorizing, can you see the common brackets? Then this x plus 2 will cancel that one. Why? Because we are multiplying. If it's x plus 1 and the plus x plus 2 all over x plus 2, you cannot cancel grade 12 because there's a plus sign in between. If there's a plus minus in between, no cancellation. You can only cancel if we multiply. There are brackets in between. Okay, I hope that one is clear. And then continue. Now we are left with the limit of x approaching minus 2 of what? X plus 1. Can you see now? No more fraction, right? And then now we can now apply this negative 2 there. It will be minus 2 for x and plus 1. The answer will be minus 1. That is the limit of that particular expression. And then the mark allocation is 4 marks. The first mark will be for factorizing that numerator correctly so. And then the second mark for simplifying and end up with x plus 1. And the third mark for substitution. Lastly, it will be for the answer. Hence, we have our 4 marks for that particular problem. Moving on, number 6. We are having differential calculus also, but in this case now is the application of rules. And then before you apply the rules of differentiation, number 1, you need to ensure that you do not have brackets. Remove brackets, multiply them out. Secondly, you ensure that you don't have the square root of x, something like that. You must write it in exponential form. No radicals, no root signs on your expressions. And then lastly, you must ensure that you don't have something like 1 over x in the denominator there. You must write it in the form x to the power minus 1 before you derive. No bracket, no root signs or sets, no variables in the denominator. Okay, and then where you are having the fractions, you simplify as far as possible, like we did on the limits. You need to simplify those fractions before you can start deriving. And the derivative rule states that now, if you are having a derivative of ax to the power n, this will, when you derive, n will multiply with an a. That means that is why we have a n there. And then from the exponent, you will subtract a 1. That is why we end up with n minus 1. What does it mean? It means that if you are having 2x to the power 5, that means it will be 2 times 5x, and then from 5 you subtract 1. That is the rule. Then you'll end up with 10x to the power 4. That is the application of that differential rule. And then there is a notation, grade 12, that you must also take care of. Your equation can be given in terms of y is equal to 2x to the power 3 plus 6x minus 2. If you are having something like that, the minute you start deriving, you must tell us that this will be dy dx. So there are specific notations that you use. So for if it is y, it will be dy dx. And then you can start now. 2 times 3, 6, and then from the exponent is 3 minus 1, that will be 2. And then if it is to the power 1, is only the coefficient of x. And then if it's a constant value, it will be 0. So we don't write that 0. We know minus 2 derivative will be a 0. And then if we are given a notation, maybe in terms of f at x equal to something there, the minute we derive, we put a dash there to show that this is now a derivative of that. And then with the one that is given to us here, it's either will be given as dx and then the bracket with whatever inside the bracket, or in this format that we see here, ddx of a certain bracket. With these two now, the minute you start deriving, the notation dx or the ddx will disappear, and then you will be left with whatever is in the bracket as your answer. So be careful around those notations, grade 12s, because if you miss a notation, you will be penalized once throughout your paper, either on the first principle or on the rules, but we will only do it once for penalizing for notation. Now, let's look at our question now. It says determine ddx bracket, another round bracket x squared plus 1 into bracket x minus 2 minus 1. We cannot derive because there are brackets that are multiplying there. The rules, we are not allowed to use this rule where there are brackets. And then it says express your answer with positive exponent. That means at the final answer, everything must be in positive exponent. So our starting point will be on removing the brackets. Okay. So now, because we are busy simplifying, we have not yet started with the derivative. We will still put that notation dx, our bracket. So we will be multiplying x to the power 2 multiplied by x to the power minus 2. Remember, we are multiplying the same base, therefore we will add the exponent. It will be 2 minus 2, which is 0. That means it will be x to the power 0 for that one. And then the second one is x squared times minus 1. That will be minus x squared. Plus 1 multiplied by x to the power minus 2. That is plus x to the power minus 2. Lastly, we have 1 times negative 1, which will be negative 1. And then we close the bracket. We have now removed the bracket that needs to be multiplied. The square bracket is for the derivative. You can't do anything about it. It's for this notation here. Okay? It will always be there next to your dx or the d over dx. And then now let's continue with the simplification now, grade 12. As we know that the exponential rules says that anything to the power 0 is 1, x to the power 0 is 1, x to the power 0, anything except 0 to the power 0 is 1. So because we are still simplifying, we will not remove this. This will be removed only if we start deriving. That will be 1 minus x squared plus x to the power minus 2 minus 1. Okay, and then 1 minus 1 will give us a 0. Then we are left with d over dx into the bracket minus x squared plus x to the power minus 2. That is the simplified bracket now. It's only then that you can start deriving. Remember, the rule says that you take the exponent, multiply by the coefficient. If there is no number here, you must know it's always a 1 grade 12. You know that one. So since we are deriving now, this d dx will disappear. We will not write it here. That is the correct notation. So it will be 2 times negative 1, which is minus 2x. And then from the exponent, we subtract 1. It will be to the power 1. And then followed by minus 2 times positive 1, it will be minus 2x. And then from minus 2, we minus 1, that will be to the power minus 3. If this indication of positive exponent was not there, we were fine with that answer. You can leave it there. But because the examiner has indicated that it must be in a positive exponent, so we need to get rid of this negative here. How do we do that, grade 12? And remember that minus 3 is only for x. Do not tamper with the minus 2, because exponent for minus 2 is to the power 1. It's a positive one. So this negative 3 is only on x. So with the first derivative here, we don't have stress. It is fine because it is to the positive one. So we are going to deal with this one. We leave minus 2 on top because minus 2 doesn't have a problem of a negative exponent. And then we'll take this to the denominator now. It will change to positive 3 because it has changed the position from numerator to the denominator. So it is now affecting the exponent sign. It is now becoming positive 3 on the exponent. So that is how we derive this particular problem. Right. And then now let's look at the mark allocation now. The first mark will be end up with this one here. Simplification of that one in that particular bracket. Number 2, the simplified when you have added the like terms and so forth. And then the third mark will be for the first derivative. The fourth mark will go to this one because it's a must that it must be positive. So if you leave it there with a negative exponent, you lose 1 mark, grade 12, because they have indicated that they need the answer with positive exponents. Okay. Right. Still on differential calculus, we are looking at the equation of a tangent. What is a tangent? A tangent is a straight line. It's a line that touches a curve. A curve, any function, can be a circle, can be a parabola, but it must touch that at one point. If it's a parabola, it must touch at one point of contact. Okay. And then now remember this equation of a tangent. A tangent is a straight line, or it's a linear function. So from the information that we know, that the equation of a tangent, we use the formula that is y original mx plus c. So if we need an equation, we must leave y and x. So we need the value of m and the value of c so that we can get that equation. Or if you don't use that original, you can use y. Some of you are using y minus y1 is equal to m into x minus x1. Okay, so grade 12, in order to be able to find that m and c, if the gradient is not given to you, that means you need to find the gradient. And then you need a gradient and a point because you need to find the value of c. That point will be substituted for x and y while you are looking for c. After finding c and m, you can now go back to the formula and substitute only m and c and leave y and x. So the important part is that I am looking for an equation of a tangent. A tangent is a straight line. So if it's a straight line, I am using the formula y is equal to mx plus c. And in order to find the equation of that line, I am depending on the gradient and the point on that particular line. If I can have those two, then I will be able to have the equation of that particular line. Let's see now what is given to us, okay? They say determine the equation of a tangent to the curve. this tangent is a tangent to the curve defined by that. And then if you look at this equation, this is the equation of a quadratic function or a parabola because it's an x squared. And then if you look at this is a minus equation, minus x squared. That means it's something like that. And then the tangent line is either on this side at x equal to 3, either that side or this side of the graph. It touches that graph at one point, right? But this equation is of a parabola. Out of this, we need to find the equation of a tangent. And then we are given that at the point where x is equal to 3. Remember, we said in order to have an equation, you need a gradient and a point. A point, we talk to a point with both x and y value, coordinate, right? Right. In this case, lucky enough, we have a point where x is equal to 3. We are only given the x value at a point where x is equal to 3. For that point to be complete, we need the y value. So we are going to substitute this x onto that parabola graph in order to find the y value. Okay, let's do that. Grade 12, that is our starting point. Okay, so that we can have a point. We take g at x. Remember, g at x stands for y. So we can write it as y is equal to 4x minus x squared. And then where we have an x, we are going to substitute with the 3 minus 3 squared. And then we put everything into the calculator now. That is 12 minus 9. And then this will give us how much? A 3 grade 12. So now, happy now. The point that you are looking for, it will be 3 and 3. Where x is 3 and then where y is also 3. We now have a point. Okay, now we must have a gradient. Remember, a gradient of a tangent is having a relationship with the derivative of a function of which is a tangent to. That means now if you are having this g at x function of which this tangent is tangent to 4x minus x squared at x equal to 3, the derivative of this function will be a gradient to a tangent. So let's derive. So we are looking at g derivative of x. Remember, if it is x to the power 1, our derivative will be coefficient, which is 4. And then for the next one, it will be 2 times minus 1 here, which will be minus 2x. And then we minus 1 from the exponent, it will be to the power 1. That is the derivative. The minute you have derived, this is now the gradient of a tangent. And then remember, this tangent is a tangent at x equals to 3 grade 12. So we are going to take that 3 and substitute for x here to get the real value of that particular gradient. That will be 4 minus 6, which is minus 2 m tangent. Can you see now this gradient is a negative 1? So if it's a negative 1, it's a decreasing function. That means it can't be this one. It's a decreasing one. From left to right is going up. It's a minus gradient there. This one, when it goes this way, is increasing. That means it needs a positive gradient. So it is, the calculation is telling us this line goes in that format. Happy now you have a gradient. You have a point. You can now look at your equation. Y, I go for mx plus c. That's the easiest for me. And then I'm going to substitute now my point here as my x and y. So that means y will be 3. And the gradient we have calculated is minus 2. And the x is also 3 there. That is plus c. Then that will be 3 equal to minus 2 times 3. That is minus 6 grade 12 plus c. Therefore, our c value, we transpose minus 6 to the side. It will be plus 6. Then 3 plus 6 will give us a 9. That is the c value. Happy? We can now finalize the formula. Will be y equal to, from this original, remember, you leave y, you leave x, substitute m, minus 2, we leave x, c is a 9. Therefore, that is the equation of that particular tangent graph. So if one of the learners maybe decide to use the y minus y1, that particular learner will have y minus y1 equal to m into x minus x1. Let's check, are we going to end up with the same thing? But now the learner will call this the x1 and the y1 because he's using the formula with y1 and x1. So it will be y minus y1 3, gradient minus 2 is the same gradient as that one, and then we have x1 is a 3, will be minus 3, and then we have y minus 3 equal to, we distribute minus 2 into the bracket, it will be minus 2 times x minus 2x minus 2 times minus 3, positive 6, and therefore y is equal to, we are transposing minus 3 to the side, it will be plus 3 there, then it's minus 2x from this one, and then 6 plus 3 will be a 9. Can you see, grade 12? Both of these learners, they will end up with the same equation. It doesn't matter which way the learner takes, as long as it is correctly applied. Okay, remember, straight line graph, you need a gradient and a point, and then if it is in calculus, the gradient of the curve is the derivative of a curve is the gradient of that particular tangent. Right, the next question, colleagues, learners, will be on cubic function. Cubic function, differential calculus, still on calculus. We are looking at the cubic function. It's either they will ask you to sketch the graph or they will give you a graph to analyze, to answer questions on that particular graph. In this case, we are given the sketch below, represent the curve of f, and then this curve is defined by f at x, the formula given to us, which is 2x cubed minus 3x squared minus 36x plus 37. As you can see, our a is positive here. That is why the graph ends up with the arm that is concave up because of positive a. And then a and b are the turning point. We are talking to this point, a and b here are the turning points of f. And c is the point minus 1 and 6. That means we took that point here. That c point here is minus 1 and 68. Okay, it's only a point on that particular graph. Nothing is indicated about it. And then now the first question says that determine one linear factor of f at x. Remember, you need one factor in order to find other factors. So here we are determining that one factor that we need in order to be able to factorize this. And then if you look at this now, we are going to substitute 1, minus 1, 2, minus 2, 3, minus 3. You can do that on your calculator, grade 12, until you find the one that is giving you a 0. And then if your answer is now 0 on the calculator after substituting this 1 minus 1, 2 minus 2 into f at x, that will be the factor. So you can check now, if we put a 1 here for x, that will be 2 into 1. We are testing minus 3 into 1 squared minus 36 into 1 plus 37. So if you put this in your calculator, that will be 2 here. This will be minus 3 minus 36 plus 37. Can you see that is 37 plus 2, which is 39, minus 36 minus 3, that is minus 39. So the answer is 0 there. So if you substitute a number and gives you a 0, you must know that number is a factor for that. It's a linear factor. Therefore, we can conclude now, if we have substituted 1, this will be x minus 1, because we have substituted as x equal to 1. So if we take it back to the side, it will be x minus 1. X minus 1 is a factor. It's one of the linear factor of that particular cubic function. And then 8.2, write down the coordinates of D. The minute it says write, there are no calculation. That means the answer is somewhere there on the given statement. You don't need to calculate that, grade 12. So they say write down the coordinates of D. So if you look at D there, D is the y-intercept of that cubic function. So to find the y-intercept, you let x equal to 0. So if we put 0 there, 2x cubed will be 0. Minus 3x, we put 0 there, it will be 0 there. Minus 36, we put 0 into x, it will be 0 there. Can you see you are left with only 37? Therefore, the y value there will be y equal to 37. Because they need this in coordinate form, we are going to write it as x and y. What is our x? X is 0, and then the y is 37. Those are the coordinates of point D. That is why they say write down the coordinates. You can just determine that from there and go straight to the answer. Right. Remember, we have calculated that D0 goes with 37. There is coordinates of D, and then we have C, B, and A there. Sorry for that. And then now 8.3, we have to determine the coordinates of B. B is that point there, which is the local maximum, and then A is the local minimum. Maximum is the maximum turning point, A is the minimum turning point. The lowest turning point, the highest turning point. So determine the coordinates of B, which is the local maximum turning point now. Okay, let's do so, great terms. Remember now, when you look at the coordinates of the turning point, you are depending on that formula, you derive it. Can you see your rules of differentiation? They play a major role in calculus. In most of the application in calculus, you are using that rule. So here we are going to derive this f at x now, still applying the rules. This will be 3 times 2, that is 6x. We subtract 1 from the exponent to the power 2. 2 times minus 3 minus 6 minus 1 from the exponent is x to the power 1. And then if it is x to the power 1 original, we take minus 36 as a derivative. If it's a constant number, the derivative will be 0. We don't write that. We know that it is 0 there. So that is our derivative, and then you let this equal to 0. And then we can divide by 6 on the right hand side to simplify that. Divide by 6, you are left with x squared. Divide by 6 minus x divided by 6. That is 6. And then we can now factorize this. We are looking for factors of 6. When you subtract, you get a 1. Remember, there's a 1 there. For factors of 6, we have 1 times 6. We have 2 times 3. Those are the only factors. But the trinomial is saying factors of 6. When you subtract, you get a 1. Can you see grade 12? You can't take 6 and 1 because 6 minus 1 is 5. So the ones that are applicable is 3 and 2 because 3 minus 2 is a 1. But to get a minus 1, that means 3 must be negative and then 2 positive, because positive 2 minus 3 will be a minus 1. Whereas when you multiply them, they give you a negative 6. Okay, now we have tested the factors are correct. Now we can now put them in brackets. It's x plus 2 and the x minus 3. So we end up with x equal to minus 2 for the first bracket, or the x equals to 3 for the second bracket. Now, grade 12, you need to be specific which one is for B, which one is for A, by relating to your graph. So if you look at B, B is on the negative x values, this side. So that means the x that is negative, it will be for B. And then obvious, the one that is positive is for A. And then in this case, we are looking for the coordinates, not only the value of x, coordinates, both x and y of B. So we are going to substitute this minus 2 into the original equation. Into original, you can't take anything in between. You must go original in order to find the y value of this. That means we are going to substitute now into x with the minus 2 on the original equation. You can even do this on your calculator without showing us. It's fine, grade 12. As long as your answer is correct, you will be the happiest. So now if we check the y value now with the x equal to minus 2, we find our y being 81. So the coordinates of B will be minus 2 going with 81. Okay, minus 2 here goes with 81. Okay, they only needed B. That is why we are not interested on A. If they needed both, we will take the A also, substitute into the original to look for the turning point of A, coordinate of A. But in this case, we were only looking for B. Hence, we have calculated only B. Stick to the question, grade 12, because if you give us both now, we are not sure whether you are answering the question or not. You must be specific as indicated on the question. And then 8.4, for which values of x is f a decreasing function. Remember, I talked to that earlier on when we were doing a tangent. The minute the graph is decreasing, that means from left to right it will go down. Therefore, we are looking at that part in this particular. The minute they say for which values of x where f is decreasing, so we go here, this side, this graph is increasing, then it's positive there. Okay, from B to A there, it is decreasing, it's going down. Can you see that? And then for that one, it is also increasing this side here because it's going up. So the gradient here will be positive, that one negative, and this one is a positive gradient. So now they say for which values of x, that means our answer will be in terms of x now. So we know as we look at this, we know this is decreasing from B to A there. What is the value of x at B? Is -2. The value of A, remember we have calculated there that the x value for A is 3. That means it's 3. So this graph is decreasing within that interval here. Can you see it's between the two numbers, -2 and x values? So the minute it is in between, our x will be in between. Okay, between what? A -2 and a 3. That is the first notation. That is why we have 2 marks. It will be for that part and this one. Correctly so, grade 12. You can't put these inequalities otherwise. Okay, you can't write them like this is incorrect notation. If they are sharing, they must always face to the right. Ne? And then now another notation, you can write this as x is an element of, because there is no equal sign there, you make round bracket starting from -2 ending at 3, and then you close that with a closed bracket, a round one. Okay, you can't use square bracket. You will use square bracket if these values were included, there was an equal sign below. It's only then that you can use the square bracket. In this case, we can't include B and A because at that point the graph is not increasing nor decreasing, it is stationary. That is why we call those points stationary. We can't say it is increasing or decreasing. At B and A they are stationary. That is why we don't put equal signs in between the -2 and 3, or we are not putting a square bracket. Right, we are still on the cubic function. Remember, we have calculated that the coordinates here, it's -2 and 81. And then we have the x value at A here, which is 3. We don't know the y value for that. And then we have calculated that D is 0 and 37. And then we have that C point there with -1 and 68. Those are the values that we have identified into that particular diagram. And then now here they say show that the equation of a tangent at C. At this point we now have a tangent now. It's a repeat question, grade 12. Can you see that? A tangent to a curve. Same method. A tangent is a straight line. You must target a gradient and a point. Happy enough, we have a point of which will be our x and y. We only need the gradient at that particular point. Okay, so now remember, to find the gradient, what do? You derive the curve. So we are going to derive this particular curve. We are showing that this is the equation of a tangent. Okay, right, derive the curve. That will be 6x squared. We have done this before on the previous question. You can only just take it from there. And then that is the derivative. After deriving, remember this is now a gradient of a tangent. I hope we are still together because we need that gradient here. Right. But this is a tangent at C. Can you see the x value at C is -1? Then we are only going to take the x value there. in order to find the actual value of this gradient. So we are taking minus 1 squared minus 6 minus 1 minus 36. And then this will give us a 6 minus 1 squared is positive times 6, that is a 6, and then a minus 6 times minus 1, that is a positive 6, and then we have a minus 36. And then minus 36 plus 6 is at minus 30, minus 30 plus another 6, that will be minus 24. Can you see, grade 12? The gradient of this tangent is minus 24, exactly the same as what is on that particular equation. But remember, we want to find the whole equation and check, is it true that it will be minus 24x plus 44? We follow our method. We now have a gradient. M of a tangent is minus 24, and then we have a point C minus 1 and 68, of which will serve as our x and y. And then now we can go y is equal to mx plus c, or you can use y minus y1, is up to you, grade 12. And then now our x, the y value is 68, the m minus 24, x value minus 1. We are looking for the value of c now, but we can see that we are expecting 44, right? Right, then this will be 68 minus 24 times negative 1 is positive 24 plus c, and then we transpose this 24 to the left, it will be 68 minus 24, and then which give us a 44. Yes, we are 100% correct. We now go original mx plus c, and then we now substitute m and c and leave y and x, y, and then gradient is minus 24, we leave x, and then we substitute c, which is a 44. Can you see, grade 12? That is exactly the formula that was expected of us. Okay, and then this is worth 3 marks. It will be, remember the derivative is done on the previous question. We are not going to allocate marks for that. It will be for finding the equation, the gradient minus 24 by substituting minus 1 into the derivative, and then the second mark will be substituting into a straight line equation, and then the fourth mark will, the third mark will be for finding the correct value of c. That is all the marks that you will get out of that, because you cannot mark this formula, it was given to us. Yours was just to prove it true. Okay. Still on differential calculus, we now go to the optimization question. It can be optimization of the rate of motion in calculus, where you are taking velocity, distance, acceleration, and so forth. Or you can be given the perimeter area, the container, volumes, and so forth in optimization. So you must be able to know all your formulas, grade 12, and then which one is for which diagram. That is very important. And then now, in this case, we are given a bathroom window is in the form of a rectangle with a semicircle on top, as you can see in this diagram there. There's a rectangle here, and then there's a semicircle on top there. So that particular window is in that shape. And then now the rectangle has the following dimensions: the 2x as indicated there, 2x by y meters. And then the semicircle is made of a clear glass, as you can see it is transparent on your diagram, and the rectangular part is made of colored glass now. Yes, it's a window, but the glasses are not the same. The other one is transparent, and the rectangular one, it is colored glass. And then this window is transmitting only half as much light per square meter as the clear glass. Okay, this rectangular part, it transmits half as much light as per the glass one. So that means the glass one is transmitting more light because it is transparent, but the colored one is transmitting half of what the light part is transmitting into the bathroom. And then the total perimeter of this window now, the whole window, the square part with the semicircle part, it is having a perimeter of 6 meters. Now we understand our statement. What does it mean in relation to real life? We can now start with the calculation. And then we are given formulas, grade 12, that the area of a rectangle, if you want to calculate, you'll use length by breadth. Area of a circle, you'll use pi r squared. Perimeter of a rectangle, you'll use 2 into L plus B, or you can use 2L plus 2B, it's the same thing. And then for the circumference, the total circumference of a circle, you use 2 pi r. But in this case, because it's a half semicircle, that will be half of 2 pi r if you calculate that half circumference. Okay. The first question states that show that the height of the rectangle is given by y is equal to that one. The height of the rectangle is given by that particular formula. Remember now, the only thing that is given to us is the perimeter, which is 6 meters. So we are going to rely on the perimeter formula in order to end up with that y. Okay, so we are going to take the perimeter because it's what's given to us, but we are looking at the perimeter of, show that the height of the rectangle is given by that. But the perimeter, remember, is for the whole shape. So if we move around this shape now, you'll be having 2x, which is this side here. And then this y side is the same as this one. Then you'll be having 2y because of y plus y. And then now for that part out there, perimeter, remember, is the total distance around the shape. We only consider the distance around. So now for this half circle here, circumference will be half. Now remember, the full circumference is 2 pi r. For that one, it will be plus half 2 pi r. Okay. Now the perimeter is given as being 6. Let's simplify this. We have 2x plus 2y plus the 2 will cancel 2. We are having pi r there. Okay. Now we want to make y subject of the formula because this is y equals to that. We are going to transpose everything, that is 6 minus 2x, and then the pi r to the side minus pi r, and then we are left with this 2y on the right hand side. And then we divide throughout by 2, all these terms, divide by 2 because we need a y equal to. Then 6 divided by 2 will be 3. And then 2 divided by 2 minus 1x, and then this one you can leave it as minus pi r over 2. Can you see, grade 12? That is exactly that. But now remember, radius is half of this. Radius is from the center to the circumference there. So if the whole of this side is a 2x, that means the radius will be x because it's half of that one. X is 2x, right? So radius is from the center to the circumference of a circle. So now you can even write this formula as y. If it was not given as pi r, maybe as pi x, you'll continue saying 3 minus x minus pi. For radius, you'll put an x there over 2. That means an examiner can change this part and say pi x there. That is what is expected of you, grade 12. Alright, next question. Show that the amount of light being transmitted through the window is L into x equal to minus x squared plus 3x. Now we are taking the light that is coming through the window. So when you talk through the window, remember perimeter, we are talking the distance around. But because this is through the window, we are talking the area now because the light will be coming through the area there. And then if you look at this now, we are looking at the area of a rectangle for this part, and the area of a semicircle, half circle. Okay, so now to have the light there, amount of light transmitted, it will be the area of a rectangle multiplied by the area of a semicircle, half circle. What is the area of a rectangle? Is length by breadth multiplied by, don't multiply, plus, sorry, we are adding the two areas, And then the area of a semicircle, remember the area of a circle is pi r squared. Because it's semi, it will be half of it. Pi r squared. Formulas are given to you, grade 12 there, fortunate enough. And then what is length? Here we are having y into the breadth of 2x plus the half pi, and then the radius, remember we said it's x, then it will be x squared there. And then now, do you still remember that we have calculated y from the previous answer? Our y was 3 minus x minus 2 okay, that was 3 minus x minus pi r, and we said this r we can write it as x, okay, because it's a radius. And then this was over 2. Then we are going to take this y from the previous answer, right, grade 12, and substitute for this y here, because our answer is in terms of x only, there is no y there. We leave 2x and substitute the y from the previous, that is 3 minus x minus pi x over 2, and then plus the half pi x squared there. Continuing now, we are multiplying this 2x into each term there. So it will be 2x times 3, that is 6x. Okay, 2x times minus x, that is minus 2x squared, right? And then the 2x times the pi r squared, that will be 2 minus the 2 will cancel the 2, then we are left with pi x squared, okay, minus sorry for that, and then the plus half pi x squared there. Okay, length by breadth, that is 2x, and then it's y 2x there, that is 2x, and then we are multiplying this out, and then we'll be left with the okay, grade 12, okay. Remember the area of a rectangle. Now we are talking that a rectangle, that will be an area of a rectangle, and then that is the half of that, ne? That is half of that, half of this, so it's half of that, sorry for that. And then here we'll be having a 3x, and then we are having an x squared. Let's repeat this step. It will be 3x minus x squared minus pi x squared over 2, and then plus this one half, it will still be pi x squared over 2, and then this part minus that one will cancel. Then we are left with the light through the window in terms of x is 3x minus the x squared. Okay, so that is the formula that was given to us initially there. All right, and then now moving on to the next question, we have to determine the values of x and y in terms of pi. Now we need x and y only, ne? Not the maximum light that is coming through the window. We need only the value of x and y in terms of a pi. When the light is entering the window, through the window, is maximized. Yes, the light is maximized, but we are not looking for the light. We are looking for x and y for the maximum light. Remember the maximum light formula is, say, Lx from the previous answer, that is 3x minus x squared. So if it is maximized, minimized, maximized, that means you need to derive this. Can you see a derivative is playing a major role? If it is to the power 1, you take coefficient 3 there. And then it's 2 times minus 1, that is minus 2x. 2 minus 1 is to the power 1. That is the derivative, right? And then now, because we are looking for x, as we are doing stationary, we let this equal to 0. And then we have 3 minus 2x minus 2 to the left, it becomes positive 2x, and then we have a 3 remaining on the right. Divide by 2 both sides, then x is 3 over 2. That is the x value. Remember, we are looking for x and y. In order to get y, we can take that formula. You remember y from 9.1, it says y is equal to 3 minus x minus pi x over 2. Then we are going to substitute the x value now. 3 minus 3 over 2 minus pi into 3 over 2 over 2. Everything into your calculator. This gives you 3 over 2 minus 3 over 4 with the pi. So they said your answer must be in terms of pi. So that is our y value in terms of pi. Now the next question, grade 12, which is our 9.4. It says, hence determine the value of x so that the greatest possible amount of light enters through the window now. Okay, remember the maximum light entering the window is using the derivative. We have already done that. There's no need to repeat. Okay, we have calculated the value of x previously. Don't repeat, we have to repeat that. After deriving, we end up with x is equal to 3 over 2. Do you still remember? We derived, let it equal to 0 and solve for x, ended up with x equal to 3 over 2. Okay, and then now we are going to look at the hence determine the value of x so that the greatest possible amount of light enters. The x value, you can't determine it again. Then we want to find this maximum, the greatest possible amount of light. So now the greatest possible amount of light, remember the formula for light is L at x, which is equal to the 3x minus the x squared from the previous question. Now since the x is the greatest, maximized, we can take this x maximized and substitute it here so that it can give us what? The amount of light that is maximum. Okay, so that will be 3 over 2 minus 3 over 2 squared. And then the maximum light that can come through that window is 9 over 4, or it can be 1 over 4 is the same thing. All the notations are acceptable. 2,25. All these three mean one and the same thing, and this will be in square units. Is it given in meters? Then it will be in square meters. Right. And then now the last topic, grade 12, will be on integration. And then with the indefinite integral, remember we have definite and indefinite integral. With the indefinite integral, we don't have the upper and lower limits. The integral is open. But we have those rules, remember, that we have indicated is on the formula sheet. So you look at the integral and relate to the formula sheet so that you can select the correct application. And then in this case now we are having determine the integral of 4 plus 2 to the power 3x dx. Remember, this is the reversing of calculus now. So in this case now, we are going to start by writing this. Remember, this is 4x to the power 0. That is why it's written as 4. X to the power 0 is 1. 1 times 4 is 4. So you deal with those first and identify all the exponents. And then now this is still in the x form. Then you relate this from the information on your formula sheet. So this one is having a relationship with the integral that is saying ax to the power n. Okay, so you go to the formula sheet and look at the relationship and take that answer. It will assist you a lot, grade 12, to be able to derive this. Remember, this one is saying k will be n to the power x to the power n plus 1 over n plus 1 plus c. So can you see that it says keep the constant? So we are going to keep 4. And then now you take x to the power 0. It says what? Add 1 plus 1. Whatever you have added, you must also do on the denominator. The same exponent goes to the denominator there. And then with this one, it is having a relationship with the one that is saying the integral of the k of a and x. You still remember that? If you integrate this one, you will end up with the a, still that and x, and then below now it will be n ln a. So you just look at the pattern, you relate this to your problem. Oh, this type, it's where x is on the exponent with the coefficient. That means now the answer must be like that. So it must start with a. What is my a here is 2. Can you see that is directing you grade 12? This a to the power as it is, it comes there. So it will be 2 to the power 3x. Remember, this is on your formula sheet. And then you go below. Below it says n. N is 3 in this case. It will be 3 in. And then what is a here? A is 2. Can you see? That formula sheet will assist you. Your answers are all in that formula sheet. And then now, this is the answer we are expecting. Let's just simplify this part here. It will be 4. And then x to the power 1 over 1 is still the same thing. By 2 over 3 in ln 2 plus c. So that is the answer. Okay, it's 3 marks. It will be for the first one, for the second, and then for the plus c there. If you don't put plus c, notation error, integration will take 1 mark from that one. Okay, 10.2, the integral. The first thing that you do, same as in calculus, you write this said in x to the power half, and then plus 6x to the power 2 minus 8 over x. And then from there now you go to your formula sheet and check the relationship. Can you see the first and the second one, they are related to that type, where you are adding 1 to the exponent and then you take it to the denominator. So that means it will be now answer x to the power half plus 1, and then whatever exponent you have is your denominator there. The same applies to the second one. You leave 6 for k, and then you add 1 to the exponent, and then denominator will be 2 plus 1. And then this one of minus 8 over x is having a relationship with the rule. If you check on your formula sheet, it is written k over x there. That means this one is now becoming k ln x. Can you see that? So now we are going to take this relationship now, bring it to that one. Okay, so k is the top part. Our top part is 8 here, and then this will be the ln of x on the denominator. Then remember your c that we have integrated. Then you can simplify this. That is half plus 1, and then half plus 1, that is 1.5, which is 3 over 2, and then over 3 over 2, plus, remember this one is actual 3. 2 plus 1 is 3. 6 divided by 3 will be 2, x to the power 3 minus 8 in ln x plus c. So the correct notation here will be 2 over 3, x to the power 3 over 2. We are avoiding a fraction over a fraction, plus 2x cubed minus 8 in ln x plus c. So it's 1 mark for that second, the third one, and the fourth mark for the c there. So our last question, grade 12, will be the area between the x-axis and the curve. And then in this case now, you are given the sketch below represent the shaded area bounded by the curve of the function defined by that. So this graph given to us here is a cubic function, a negative, as you can see the last part is facing downward. And then the area is the shaded area there. As you can see, between x equal to 1 and x equal to 4 there. That is the area within those boundaries. They say show that the area of the shaded region is not greater than 62. That means basically you need to calculate the area of that particular boundary. So we are applying the integration, but we call this the definite integral because we are given the interval there. It will be definite, okay? And then on top, your upper limit will be the highest number, the lower limit will be the smallest number. Of what? Of the equation that is given to you, minus x cubed plus 6x squared of the graph given to you. And then that is dx. Can you see still our integration? And then we are going to integrate what is inside. We change the bracket to square bracket now. Then when you integrate, remember it will be minus x to the power 3 plus 1, and then 3 plus 1 on the denominator, plus 6x squared 2 plus 1, and then 2 plus 1 on the denominator, square bracket. And then we are deriving this, which we are integrating within the interval, upper interval 4, the lower one is 1. The notations are very important, grade 12. You cannot write as you like here, okay? And then now let's simplify now and find the final integral is minus x to the power 4 over 4 plus, remember this is 3, 6 divided by 3, 3, 6 is 2, x to the power 3 within the upper limit 4 and lower 1. The next step, now we are substituting the limit now. First bracket, it will be minus, we start with the upper limit, the bigger one, that is minus 4 to the power 4 over 4. We are going to substitute the x's now. And then plus 2 into 4 cubed, that is the substitution of 4. And then minus, we now substitute a 1. That will be minus 1 for x to the power 4 over 4. We are substituting in here, grade 12, and then now 1 into that one, it will be plus 2 into 1 to the power 3. Can you see after substituting, we don't write those limits anymore, the upper and the lower one. And then you put everything into your calculator, straight to the answer. It gives us 62,25 square units because we are looking at the area there. Now they said, now show that the area of the shaded is not greater than. Can you see now? This is 62,25. Remember this one is 62,5. Can you see this one is smaller than that one because comma 5 is half, comma 25 is a quarter. And therefore this is less than 62,5 units squared. You can write it in words or you can indicate with the less than, it's fine. Or you can write in words as it is less than what is given to us. Okay. So grade 12, this brings us to today's lesson. This lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. See you next week. We will be revising our paper 2. Thank you.